Yeah, good afternoon. This video is all about long division and partial fraction. So, for example, you have here long division. You have 2x squared plus x minus 3 divided x minus 1. So, first, take this first term, divide by x, you have 2x. 2 times 2x times x is 2x squared. 2x times negative 1, you got there, negative 2x. Okay, you subtract this one. Okay, when you subtract, okay, subtract this one, of course, this one will negative and this one will become positive. Okay, this one will cancel out, become 0. And then this one will become positive 3x. 3x divided x is 3. 3 times x is 3x. 3 times negative 1 is negative 3. This negative 3 is going to put here. Okay. When you subtract all this one, so it will become 0. Okay. Okay, so the same true with here. Okay. Here. Okay. Wait. So I can, okay. So the same true with here. You have 3x squared divided x is 3x. I don't know, this is 3x cubed. Divide x is 3x squared. Then go back, 3x squared times x is 3x cube. Okay, it's 3x cube. 3x squared times 1 is 3x squared. When you subtract, this one will become negative, this is negative. Thus, you have here plus x squared, and then negative 3x squared will become negative 2x squared. Okay, so how about this one? Put this back here, put this down, and then again 2x squared divide x will become negative 2x, and then multiplying going here will give you negative 2x squared. This one multiply 2, 1 will become negative 2x. And then when you subtract, this one will become positive, this one will become positive. That's why this becomes positive 5x. Okay, 5x divided x is 5, and multiply this one here, becomes 5x. 5 multiplied by 1 will become 5. Oh no, 5 here. 5, put it down, then you can have here 0. So the same case with here. I don't need to discuss this further. Okay, the same solution, the same approach. Now let us come to partial fractions. When you can see this one, obviously, you cannot divide, cannot use long division. So what you need to do is to use the partial factors. This is linear partial factors. From this formula, if you still remember this one, up here, if you have this in this form, you can write in this manner. Similarly, if you have this the factor of 3, the power of 3 of power 2, you can have these repeated linear factors. And if you have a quadratic equation, you can write in this manner, combination with a linear factor. Okay. So this one is a linear factors. Okay, you have A and B if you only have 2. So you have, okay. Okay. So this one, you have this, and here is the factor of this. Of course, we get the factor first of this. Okay, when are you going to use linear factors? Take a look here. You're gonna do a long division. So what you need to do is to use linear factors. In this case, with the factor of this one, you have x plus 3x minus 1. And from our formula, that you could write this form in this way. Here a over x plus 3, and then here b, and then x minus 1. Okay. To combine this one, you have this as your less common denominator. It's just simply multiply cross division. X minus 1 times A, you have this one. X plus 3 times B, you have this one. Just copy this one, put it here. Okay. So from here, you copy this one, 11 minus 3x. Of course, when you divide both sides by this one, this will be, okay, this will be our remaining values. This one, and then this one. That's why we write it here. And from here, you can compute now the values of A and B. If you assign values of X. Okay. For example, here, try to look for a value that would eliminate one variable. It's either A or B. Now, if you have 1, if your X is 1, 1 minus 1 is 0. So here, let us substitute when X is 1, 11 minus 3 times 1, which is 3, plus 11 minus 3 is equal to 8. And this one obviously will become 0. And then here, 1 plus 3 is 4B. So from here, you can get B is equal to 2. Now, if you're going to eliminate this part, X minus 3 plus 3 becomes 0. So when X is equal to minus 3, substitute it here, minus 3 and minus 3 is positive 9, plus 11 becomes 20. Here, minus 3 and minus 1 is minus 4 times A. You have this one. Obviously, this one is 0. Minus 3 plus 3 is 0. So here, you can compute the value of A. And now from here, substitute the value of A, and value of B. You can have in this form. So this will be the partial fractions, the equivalent form for this particular function. Okay. Now, what's the purpose of this one? If you are doing evaluation of integration, this could now be easily be evaluated compared to this original form. This one will be difficult for you to evaluate that in terms of, let's say, integration. Okay, another example. This is again linear fractions, linear factors. So you have, since you have 3, you have A, B, and C. Again, these are your least common denominator. If this one is divided by x plus 1, of course, x plus 1 will be removed. You have x minus 2 and x plus 3 will be multiplied by A. So you have in this form. Similarly here, just remove x minus 2, you have x plus 1 and x plus 3 multiplied by B. And then here, if you have in this part, of course, just copy plus here. You will just remove x plus 3, you copy x minus 1, x plus 1 and then x minus 2, you have this one, and then multiply by C. And from here, you can write in this form, copy this one, and then this numerator, copy it from here, copy it here, and then look for the values of the A, B, and C. So the same with our previous example, we will start assigning values. Let us say x minus 1. If we have x minus 1, this one, of course, will be eliminated, or this will become 0. So we can have values here. When x is minus 1, this is 2, this is positive 9, and then of course you have negative 35. Here, this one, x minus 1, 1 minus 2 is negative 3, minus 1 plus 3 is positive 2. Here it becomes 0, and then 0. That's here you can compute the value of A. If you assign value of 2, x is equal to 2, you can eliminate this part here. So, okay, let's substitute again. 2x squared, or 2 squared is 4 times 2 is 8. Minus 9 plus times 2 is negative 8, and you have negative 35. If you have here 2, this will, of course, this will become 0. 2 plus, if you substitute here, 2 plus 1 is 3, and then 5, this one. And then here, if you have x is 2, of course, you have to get value equals to 0. So simplifying further, you can have this minus 45. You have 3 times 5 is 15. You can compute the value of B. And continue with the substitution. You have your negative 3. Why negative 3? X is equal to negative 3. So that we can eliminate this part. Okay, this plus 3. X plus 3 minus 3 plus 3 is 0. Similar also in this part. So substituting here, it will still give you these values. Okay, 18 by 3 squared, negative 3 squared is 9 times 2 is 18. Negative 3 and negative 9 is positive 27. So you have here. And then here, you have 0, 0, and then compute the value of C. Once you have A, B, C, you have C, you have B, and then you have A. Therefore, you can go back from here and then substitute here A, what is A, what is B, and what is C. Okay, how about this one? If you see the degree in numerator and denominators or are the same, the degree is the same, then you can just first try the long division. So obviously you will come up with this value. Okay, 1, if you divide this x squared plus 1, divide by this of here, you can come up this one. Okay, you have x squared divided x squared is 1. Then going here, you will come up this remainder. This is 3x plus 1 divide this one. And this is a form that we could utilize partial factors. This is linear factors. You have A and then B. The same solution that we had in the first example, you can compute for A, and then you can compute also for B by assigning values. Here, you assign here x is positive 1, you can compute B. You assign x is equal to 2, you can compute A. So we have in these values. Okay, how about this one? This is again similar to the previous one. This one is bigger in degree. This is 3, this is 2. So obviously you can have long division first. So you can come up with x minus 3, and then the remainder is 6 minus 1 minus x minus 10 over this one. And then this one's again a partial factors, which you can compute A and B. In other words, you have here the value of this one is just x minus 3 plus this is with A and this is B, which you computed using partial factors. Okay, how about this one? This is repeated linear factors. So first you have A, here you have x minus 2, and then B, you have here from 1 becomes 2. And then you combine like this, just multiplying like that. Okay, so you have A and then x minus 2. No, it's just x minus 2 because if you're going to divide x minus 2 squared by x minus 2, you have x minus 2 remaining multiplied by A. And then here, you cannot do this cross multiplication, okay? X minus 2 cube divided by x minus 2 cube is 1. We'll just cancel out. So you just copy here B. Okay, so from here, you can compute A and B. Of course, you copy first this one, put it here, and then this numerator, put it here. You can compute values of A and B by assigning values. When x is 2, obviously this will become 0. You can compute the value of B. Okay. And then the other method that you can have, take a look with the coefficient. Coefficient of x. Let's say we use coefficient of x. What's the coefficient of x here? This is 2, right? Coefficient of x here, this is A. So meaning A is equal to 2. About the constant. What are the constants? Here, the constant is 3. Copy it here. Here, the constant is, you have your negative 2A. A is part of the constant. B is also constant. Since you have A is equal to 2, you can compute the value of B. But this one, just to check, because we already calculated B earlier. Now, if you have this combination of linear and then repeated factors, so A first for x plus 3, and then B for x minus 1, and then it's repeated, you use C. Combine this one using this as our LCD. Again, if you divide this one by x plus 3, you just remove x plus 3, and then you multiply by A. You have in this form. Similarly here, you remove x minus 1, so you have here x minus 1, and then that's x plus 3, multiply to this value of B. And here, you just remove x minus 1 squared, you remove this one, multiply by x plus 3 to C. That's why you have this form. Okay, from here, you can also assign values of x. Obviously, if you have x is equal to 1, this will give you the value of your c. Okay, and then if you have x is equal to -3, this will cancel out also this one. You can come up with the value of your a. And now, for you to get the value of c, you can also get the coefficient of, let us say, x squared. Another method that you could get the values of your variables. Or yes, the coefficient of 5x, the coefficient of x squared in this side is, you see, you have 5x squared, coefficient is 5. Here, the coefficient of x squared, if you are going to expand this one, this becomes, okay, okay, okay. If you're going to, expand this one, this will give you x squared minus 2x plus 1. So looking at here, what is the coefficient of x squared? If you distribute a, this will become, of course, a. Here you have also a here, and then here you have also a. So the coefficient of x squared here is what? A. Okay, the coefficient of x squared here is you have a. So similarly here, if you're going to expand this one, you also have x times x is x squared, the coefficient is b. That's why you have real b. Since we already calculated a is equal to 2, you can compute the value of b. Okay, and similarly, you get also the coefficient of x. Okay, the coefficient of x here is -2. Here, it's 2x, 2ax, so you have here -2a. Here you have, if you are going to distribute this one, 3x, okay. Expand this one will become, okay, this one will become x squared. 3x minus x is 2x, and then minus 3. So obviously the coefficient is 2 times b. That's why you have here 2b. Okay, and then here for c times x is cx, coefficient is equal to c. We have the values of a, we have the values of b. Okay, this is for you to check, which earlier you already calculated what is the value of c. Checking or just in the start, getting the values of a, b, and c, you can use values of your coefficient of x squared, coefficient of x, or maybe constants. This one is this one is again repeated. This one should be 3. Okay, this one should be 3. Repeated linear factors. So x plus 3, a, here b squared, and then cube c. So the same approach, come up with this by combining these 3 fractions, and then copy this one, all of them here, and then copy this. Okay, you assign values. You can, here x is equal to -3. You can compute the value of this c, and then from there, you don't have any assigning of values which could eliminate some parts here. So just get the coefficient for x squared. The coefficient here is 3. Here the coefficient is a. Here no more x squared here. For the constant here you have 16. Constant here you have, I think, 9a x. Okay, constant here 16. Here the constant is here 16, I should say. Here, if you are going to, I was lost. If you're going to expand this one, it will become x squared plus 6x plus, okay, 9. Multiply by a, so you have 6 times a. Because a times 6 will give you 6a. This is the coefficient of x. Here, the coefficient of x here is b. Okay, so from here, you can get the value of b. If you're going to check, you can use with the constants. And then here again, this is a combination of linear and quadratic. So again, in quadratic, just to remember, you have in this form, okay? If you consider this quadratic form, a denominator should be ax plus b, or it could be bx plus c. If you start here instead of c instead of c, you write a. Okay, so in this case, you have x plus b, and then copy this one, and then x plus 1 copy. Just continue a, b, and here you have c. Combine this one, and come up with this. Okay. Again, how to do it? This one divided by x squared plus 2, just have remaining x plus 1 multiplied by this ax plus b. So that's why you have this form. Okay. You have this form. So here you remove x plus 1, you got here x squared plus 2 multiplied by this c. Copy this numerator, can write it here, and then copy this numerator again from the left side. Assign values. If you assign here x minus 1, obviously this one will cancel out. You can compute the value of c. Minus 1 squared plus 2 becomes 3. So you can get the value of c. Now, you can also get the values of, let's say, a by identifying the coefficient of first x squared. You have here 7, x squared here, ax, and then x becomes x squared. So that is ax squared. So you have the coefficient of x squared here is a, in this part. Here, the coefficient of x squared is c. We have already computed the value of c, which is equal to 5. Thus, we can compute the value of a. For x, coefficient of x here, we can find the value of b. From here, the coefficient of x is 5. Here, the coefficient of x is, obviously, this is b. No, here, the coefficient is coefficient of x here is a. If you are going to distribute ax times 1 is ax. Then you have also b times x, bx, so just copy b. Here, we don't have x variable. So our coefficients are only coming from, coefficient of x is only coming from here. Expand this one. Ax and x is ax squared. Ax and 1 is ax. The coefficient is a. B times x is b. So from here, since a is already calculated to be equal to 2, we can compute the value of b, which is equal to 3. You can check if this is correct using the constants. This last example is a repeated linear factor, and then you have quadratic. So repeated, you just have to write this one, then a and b, or quadratic, you have 6 plus d. Combine this part, okay, combine this one, you can have this, okay? And then copy the numerator, and then the numerator on the right side. Start calculating the values with the coefficient starting with x squared, x cube. X cube here, you have -2. X cube here is, you have a. Here, nothing. Here, 6, and x squared is 6 cube. You have here this value. Okay. You can also try the value of x equals to 0. When it's 0, this one will become 0, 0, 0. What is remaining here is 3. Here becomes 0. Here is 0. This one is 3b. That's why you can compute the value of b. Get the coefficient of x squared. Coefficient is here is 4. Coefficient here is nothing. Coefficient here is b and x squared. You have b. Coefficient here is d and x squared. You have d. You can compute the value of d since b is already equals to 1. And then coefficient of x here is 6. Here is 3a. Here, no more x. So a is equal to 2. So you can compute this kind of fraction with this method. Okay, so we have now the equivalent partial fractions. So I think that's all for long division and partial fraction. What you need to recall is only this formula. So that's all. Thank you.